Hello, geometry. This is the start of chapter 7, 7.1 angles of polygons, and this is Mrs. Peterson here. So to start us off, we have the essential question: what is the sum of the measures of the interior angles of a polygon? What is the sum of the measure of the exterior angles? So make sure that you're writing this down at the top of your notes under 7.1, and then go ahead and move on to the left-hand side. So press pause, record this, and then go on to the left-hand side. So a reminder, by this triangle sum theorem, the sum of the interior angles of a triangle is 180 degrees. Okay, so that means that when you add up all of the angles of a triangle, no matter if they're all the same or if they're all different or two of them are the same, it doesn't matter. When you add them up, you will always get a total of 180 degrees. Well, on this chapter, we're going to be talking about not just triangles, we're going to be talking about quadrilaterals, decagons, pentagons, and even 20-sided figures or 11-sided figures or 15-sided figures. Okay, we're going to be able to, at the end of this lesson, know how many total degrees there are in a figure with multiple sides other than 3. So the first thing that I want you to do is, you're going to do this on your own, but I'm going to get you started. You're going to figure out how many triangles can you cut this into. Now, don't cross any diagonals, okay? Start at a vertex and make a diagonal. Now, there's no other diagonals that I can make that go through the center of this figure, so there's only one diagonal. So now your question is, well, how many triangles do I have? Well, I've got 2. I've got one with 180 and another with 180, because a triangle has 180 degrees. So quadrilateral has a total of not just 180, but another 180, which is 360. Okay, now go ahead and think about a pentagon. Quadrilateral has 4 sides, triangle has 3 sides. Now how about a 5-sided figure? Okay, so once again, start at one point. It doesn't matter. Don't go to a consecutive. We'll talk about this. Don't go to a secutive vertex. You want to go to ones that go through the center of this polygon. So now we have not only 1 triangle or 2 triangles, we have 3 triangles. So 180 times 3 is 540, and you could do the same thing with a 6-sided figure. Start at a vertex. Okay, now think about it. We've now got not 1, 2, 3, but we have 4 triangles, which means that we've got 4 times 180. So what I'd like you to do is, I'd like you to fill out the rest of this chart. It's on the left-hand side of your page. Okay, triangle has 4 sides. Quadrilateral, whoops, not 4. Hello, Mrs. Peterson. Triangle has 3 sides. Quadrilateral has 4. Pentagon has 5. Hexagon has 6. Heptagon has 7. Octagon has 8. Nonagon has 9. And just so you know, a decagon has 10. And then you might even see things called n-gons. This is when you don't have a special name for a figure, so based on the number of sides. So let's just do a 13-gon, okay, or an 11-gon, since that's the next one. That has 11 sides, okay, or a 15-gon. I don't have a special name for that, so that has 15 sides, okay? So go ahead and fill out the rest of this chart. How many triangles are within a triangle? Well, there's only 1 triangle, and we talked about that the sum of the interiors was 180. Okay, quadrilateral had 2 triangles, so 2 times 180, well, that was 360. Okay, pentagon, 5, well, the number of triangles in that, if you go back to our previous slide, was 3 triangles, and then a hexagon had 4 triangles. So 3 times 180 is 540, and 4 times 180 is 720. So go ahead and figure out what the rest of these are. Go ahead and pause the video. Okay, so as you went through and filled this in, hopefully you saw some kind of a pattern happening here. Okay, so the number of sides minus 2 was 1, and then you multiply by 180. Sorry, multiply by 180. Okay, number of sides minus 2 was 2 times 180 is 360. Number of sides minus 2 is equal to 3 times 180 is 540. So you could go ahead, if we had n number of sides, please add this to your chart, okay? If you have n number of sides, well, we'll say n number of sides, well, how many triangles? Well, there will always be an n minus 2, which will create your how many triangles there are. That will always happen. And then what you're going to do is you're going to take n minus 2, and then for each triangle, which once again, this represents a triangle, you're going to multiply by 180 degrees. Please, please, please highlight, circle, whatever you need to do with this, okay? So let's go to the right-hand side of our notes. In a polygon, two vertices that are endpoints of the same side are called consecutive vertices. A diagonal of a polygon is a segment that joins two non-consecutive vertices. So we have a picture here, and I forgot to copy and paste that picture. I'll draw it really quick. Hopefully you understand my drawing, okay? It connects two non-consecutive, meaning not in a row, okay? So if you look at this, that's non-consecutive, that's non-consecutive, and then we also have this. So technically, consecutive would mean right next to. We don't want to connect that. That doesn't make a diagonal. So in this case, we have a six-sided figure, so a hexagon, and it has 3 different diagonals. Actually, there's more than that because you could go ahead and do all of these. So kind of think about how that would all look with diagonals. Okay, polygon interior angles theorem. You guys just did this on the left-hand side with our exploration. So it says the sum of the measures of the interior angles, and I want you to do this. The sum, please highlight, of interior of the angles of a convex n-gon is n minus 2. Always do that first, and then multiply by 180. This will give you the number of triangles, and then multiplying by 180 will give you the total degree measures. So let's go ahead and try that. Find the, and once again, I need you to have a highlighter or a different colored something ready for this lesson, okay? Find the sum of the measures of the interior angles of a figure. Well, let's look at this. 1, 2, 3, 4, 5, 6, 7. There's 8 sides. To find the sum, your n is the number of sides. So there are 8 sides here. You're always going to subtract 2. Once again, that means that we have 6 triangles. Well, we take each of our triangles and multiply, that's a multiply, by 180. So we've got 6 times 180, and that gives us 1,080 degrees in this figure. So if you were to add up all of the angles, you get 1,080 degrees. Okay, go ahead and try this one on your own on the left-hand side. This is number 1. The coin shown is the shape of an 11-gon. So think about the number of sides and what you have to do to find the sum of the interior. Once again, I would highlight that if I were you. So go ahead and try this out, and I'm going to go to the next slide to show you the answer. Okay, you should have gotten 1,620. Okay, example 2, going back to the right-hand side of our notes. Once again, I want you to highlight or box sum of the measures of the interior angle of a convex polygon is 900 degrees. Okay, not each. The sum of the measures of the interior angles of a convex polygon is 900 degrees. Well, if the sum is 900, what is the polygon? Well, we don't know the number of sides, so we have to figure that out. Well, 900 degrees is equal to n minus 2 times 180. So the first thing you do is you divide by 180. That will give you the number of triangles in this polygon. So n minus 2 900 divided by 180 is 5, but this gives us the number of triangles. We want the number of sides, so you are going to add 2 to both sides. 7 is the number of sides. And then it says to classify the polygon. Well, this is a heptagon. And you can go back to the left-hand side of your notes and go ahead and look up the names of these. Okay, go ahead and try this on your own. You've got a polygon that has a total interior measure of 1,440. How many sides does it have? Okay, you should have gotten that it has 10 sides. And that is called a decagon. Not on your chart. Maybe I did put it on there. But make sure that is added. Okay, so you guys have a corollary to the polygon interior angles theorem. Well, guess what? Not only are there interior angles, there are also exterior angles. Oh, actually, sorry, I'm getting ahead of myself. The corollary to this is that there's a quadrilateral, and I want you to always know that quadrilateral has 360. Quadrilaterals we work with a lot, especially in this chapter. After this lesson, every single lesson after this in the chapter is based off of quadrilaterals and the special quadrilaterals that we have. So 360 is going to be the big number here. So it says find the value of x in the diagram. Well, because it has 4 sides, we already knew that the sum of the interior was 360. Okay, no need to take 4 minus 2 times 180. Okay, this is going to be one you'll memorize. So what you're going to do is, this is what the sum is, and the sum needs to add. So start somewhere, it doesn't matter. X plus 108 plus 121 plus 59 equals 360. So add all of those up, and you get 288 equals 360. Now subtract 288. X equals 72 degrees. We're trying to find this missing angle based off of the other ones that were given. 72 is the only measure that can be left there. So go ahead and try this one on your own. Once again, it's 4 angles because there's an X, a 3X, a 5X, and a 7X. Find the measure of all of them. So when you find X, hopefully you got 22.5, you're going to go ahead and plug it in. Now, one way to check your answer is if you were to add all of these up, do they equal 360 degrees? Okay, so that's one way to double check your answer. That is how I checked my answer. Okay, in an equilateral polygon, I want you to add, so equilateral, lateral meaning sides, all sides are congruent. Highlight this, okay? All sides are congruent, and then go ahead and draw that picture. In an equiangular polygon, that means that all of the angles, highlight this, are congruent. All the angles on the interior are congruent. And then a regular polygon is a convex polygon where both, here's the key word, both sides and angles, or I should say equilateral and equiangular. If you want to add in there, all sides and angles congruent, okay? And then it gave you a picture there. If you want a better picture, an easier picture to draw would be an equilateral triangle. It is regular if all the sides and all the angles are the same. Okay, so let's move on. We know that regular means all sides and all angles need to be equal. A home plate for a baseball field is shown. Is the polygon regular? Well, let's look at this. It looks like all of the sides could possibly be the same length. Okay, AB maybe looks a little bit longer, but it's kind of hard to tell. They don't give us any information on that. So now let's tackle. So are the sides congruent? That's a question mark, okay? But how about the angles? Are the angles congruent? And let's look at this. This says that it's 90 degrees, 90 degrees. These two are the same, but it's not 90, and this is 90. So because all of the angles are not equal, you would say no, not all angles are congruent. Okay, so not all angles are congruent. For part B, it says find the measure of C and E. Okay, so let's do a little bit of work here. It has 5 sides. So 5 minus 2, this is the interior, times 180. So 3 times 180 is equal to 540. So that means that when I add 90 plus 90, and I'm going to call these both x because they are the same thing, because they have the same arc mark. So know that E and C, they are the same. So I'm going to say plus x. So I started here. I did 90 plus x plus 90 plus x. Now it had 5 sides, so that means it needs 5 angles. So just double check. 1, 2, 3, 4, 5. We got it, and it adds to equal 540. So go ahead and simplify this. 90 plus 90 plus 90 is 270. And then x plus x is 2x. Subtract 270. And then divide by 2, and you get 135. And this is the measure of angle C, which is also equal to the measure of angle E, which is equal to 135 degrees. Okay, so go ahead and try this one, number 4 and 5 on the left-hand side on your own. Okay, so this is me sketching a pentagon that is equilateral but not equiangular. So I just showed not all angles were equal. And then here, this is finding the measure of angle S and angle T. Once again, they were the same, so I designated both of them to be X. Okay, this is the one I was talking about earlier. I was jumping ahead of myself. So the Polygon exterior angles theorem, go ahead and fill this part in. The sum of the measures of the exterior angles of a convex polygon, one angle at each vertex, is 360 degrees. So the interior sum is trickier because you have to take n minus 2 times 180. But the exterior sum, guess what? There is no math work to do other than to say, well, guess what? No matter what, it's 360. Okay? When you add up all of the exterior. Now, the exterior comes from basically you extending one of the sides of the angle. So 2 is an exterior. 3, 4, 5, and 1. All of those are exterior angles. They're on the outside. Okay, but I also want you to notice what happens with an exterior and an interior. Think about how many degrees they're going to always total. We'll get to that in a second. So I just wanted to, we'll see if this shows up here. I wanted to show you what happens here. So we'll go ahead and play this, and it shows you exterior angles. I got to get rid of my pen apparently. Okay, so this is creating exterior angles. Okay, and then I want you to see what happens when we put all of the exterior angles together. Look at how many degrees it equals. It doesn't matter how many sides or what the degree measures are. They need to always add to equal 360. I really like that one. So hopefully that kind of painted a good picture for you as to why and how that works. Okay. So now let's move on to example number 5. So find the value of x in the diagram. Now, first of all, look at where it's located. We are on the exterior, okay? So what you're going to do is you're going to add them. I don't care where you start. X plus 2x plus 89 plus 67. Well, the exterior, there's no work to be done. It's just always 360, okay? So you add all of those together. So when I add 89 plus 67, I get 156. And then when I add x plus 2x, I get 3x. Okay, and when I subtract 156, I get 204. So x is equal to 68. And it asked for the value of x. And so I know I'm done because that is the value of the x. Now, if you wanted to plug it in and check that they add to equal 360, that'd be a great way to check your answer. Okay, here you need a highlighter or just something with a different color. That would be great. But in the image below, highlight one exterior angle at each vertex. And then here you have a hexagon. And it has the following exterior angles. What is the measure of the exterior angle at the 6th vertex? Notice a hexagon has 6 sides. They only give you 1, 2, 3, 4, 5. Okay, here are your answers. Oops, I forgot to do the last one. Okay. Sorry about that, everybody. Here is the answer to that last one. So once again, there are only 5 angles given and we need 6. And we're talking about exterior angles. So instantly you should remember that this is 360. And this is what I get, 77 degrees. Okay, here we go. Last example, the trampoline shown is in the shape like a regular dodecagon. By the way, dodecagon, another one to write down or maybe circle or highlight. This has 12 sides. Okay, find the measure of each interior. Okay, this is the really important part. Highlight each interior. So all the way back in example 1, I had you guys highlight sum and interior. Well, guess what? We do need the sum, but we got to go a step further when it says each. Okay, so by the way, remember it's regular, so all angles are equal. Okay, so they're all the same. So let's look at the interior angles. We can find each of them once we find what the sum of all of them are. So we're going to take 12 minus 2 times 180, and that's equal to 1800. Now this is the sum of the interior. That's not what it's asking for. What we need to do is we need to find each interior as long as it's regular. Okay, and we're going to divide the sum by how many sides there are, how many angles there are, 12. Okay, so you're going to divide by the number of sides, and this is equal to 150 degrees. This is what they are, each of them are. Okay, now the next one, when you do exterior, it's so much easier. You don't have to go through all of this work. We know that the exterior sum is 360. That's the exterior sum. Now to find each, since they're all the same, you're going to divide by the number of angles there are, and you get 30. Oops, I said 30. That's right, not 36. Now I want you to make a side note. What is 150, the interior, plus 30? And I said this in the beginning, you've got an interior and an exterior, and they create a straight line. This will always be 180, always. So if they give you each interior, you should be able to find each exterior very easily by just taking 180 minus the interior, or vice versa. Okay, go ahead and try this one on your own. Remember, pentagon, if you have to look it up, that's a 5 sides. So you're doing the same thing, each interior for 5 sides, each exterior for 5 sides. And hopefully once you get the interior, it's super easy to get the exterior, or maybe you even want to take a shorter route, find the exterior and then get the interior. However you decide, that works well. Okay, so this is what I got here. 108 and 72, when I add them together, I get 360. So I know that I did that one correctly. Okay, good luck with the homework.